So quick general information. 2p factorials, they're experiments that contain a p amount of factors. P is very arbitrary. It's just how many factors you have in any given experiment. And you test these factors at two different levels, very high and very low. This is a great way to narrow down large amounts of factors in an experiment to figure out which factors are useful and which are not. The general basis for these types of experiments is so you can simultaneously study the effect of the p different factors on a specific response variable at two extreme levels, the extremely high and the extremely low. So blocking is extremely effective in reducing your variation that can arise from any unrelated sources, and it makes it very easy to identify what is actually going to be useful to your experiment. A downside to blocking is that when these 2p conditions are broken up and placed into the homogeneous 2r blocks, 2r minus 1 factor effects cannot be estimated. It's impossible to do with blocking. So fractional replication is another special case in 2p factorials, and it's used mostly when the number of p factors is very high. Although fractional replication gives lots of good information, it will never give you as much information as doing the entirety of the 2p factorial experiment. Two p factorials are really mostly used in very large industrial experiments that they have an extreme amount of factors that need to be considered, and they're trying to save themselves time and money by getting rid of all the factors that are not going to be useful to them. They're primarily used in the beginning stages to screen out, again, these factors that will or will not be useful. And these 2p factorials can give a lot of preliminary information about how each factor can affect the experiment. So 2p factorials were used in an experiment where engineers were trying to figure out the decoloration of wastewater. And the factorial experiment were used as a screening experiment to just help these engineers quickly get rid of any factors that were not relevant to the decoloration. So the main reason to use 2p factorials is it's quick and efficient way to root out any factors that are not going to be relevant to your experiment. It's a fantastic way of putting yourself on the right track to finding factors that are important and can often save you lots of time. And so if a particular experiment is expensive, it can save you lots of money as well.